Hello everyone. Good morning to all of you. Good afternoon. Okay. Good afternoon to all of you guys. Uh, I hope my voice is clearly audible to you all, and also my screen is visible clearly to you all. Is everything okay to start the class? Hello everyone. Good morning. Okay. Done. Let me know in the chat box, everyone. Okay. So in your first class, because I think tomorrow you are having unit test, right? Tomorrow you are having unit test, okay? Okay. So in the first class, what we'll do from the fundamentals of mathematics chapter, we have one important topic, that is inequality. Okay. So we'll continue this topic in this class, in this session. Okay. So what are the concepts coming under inequality? Let's see. Okay. Just a minute. Yeah. So these are the concepts we'll cover in this class. Now we'll see what is linear inequality. Then we'll see how we can solve linear inequalities with one variables and also with their graphical representations. And then we'll see the most important methods, that is Weber method, to solve the inequalities, okay, involving polynomial or rational functions, okay. By using the Weber methods, we can solve those inequality, okay. Then we'll see inequality involving logarithm and modulus functions, and some miscellaneous inequalities we'll see. Let's see. Definitions, all of you know inequality क्या होता है ना? Equality, when we are giving between two expressions equal signs, then we can say they are equality, or we can say equations, okay. In when we are giving inequality sign, like here you can see one example, 5 is not equal to 7. So how we can represent it mathematically, that is 5 is less than 7, is it or not, है ना? So this is one inequality, ठीक है? To compare two numbers or to anything, to compare two numbers are not equal, but it does not tell that whatever is less than or greater than, okay. If we have to compare something, then we use other inequality symbol, okay. Don't worry, no need to go through all these theories, okay. Just you know what is inequality, to compare two numbers, okay. Two numbers, suppose, or two expressions like this, 5 is less than 7, okay. This is one inequality which is less than, and all of you know what are the symbols of inequality, signs of inequality, that is, this is greater than, less than, greater than equal to, less than equal to, all of you know these things, okay. No need to explain these things again and again, okay. So these are few examples how the inequalities look like, है ना? 3 is greater than 2, 3 is less than equal to 5, है ना? 30x is less than 200, okay. These are few inequalities we are given in the examples, okay. Chalo. Next is, now we'll see algebraic solutions, how we can solve the linear inequality with one variable algebraically. Let's see. Okay, this is, leave these things here, no need to go through it all. Okay, so the main thing is rules of inequality, है ना? Main thing is rules of inequality. Let x, y and z be real numbers. Suppose you have three real numbers, है ना? Addition property is saying if x is less than y, then x plus z less than y plus z. That means when we are having, see, when you are having the inequality like this, x is less than y, okay, x is less than y, so we can add any number to both sides, ठीक है? कोई भी नंबर को हम दोनों साइड में ऐड कर सकते हैं. Like here we are adding z, x plus z less than y plus z. This is one rule first. In inequality, we can add any number to the both sides. Subtraction, similarly, we can subtract also. Suppose here one inequality is given x is less than y, then we can subtract z from both sides. This is the second rule. Okay? And third rule is saying multiplication property. Okay, multiplication property is saying this is first, second, third. Multiplication property. When suppose x is less than y, one inequality is given to you. Okay, suppose x is less than y. Let's understand all these things very clearly. All of you, I am requesting to all of you, please join the audio. Please, all of you join the audio. I can see here few members didn't join through audio. Join the audio first, join the class and be interactive in the class. Okay. If x is less than y, so when we can multiply, there are two conditions. When we can multiply both sides of the inequality. If z is greater than 0, if z is greater than 0, then if you are multiplying z with both of the side of the inequality, that means if you are multiplying z to the both side of the inequality, xy, xz into yz, then the sign of the inequality remains same. Okay, then the sign of the inequality remains same. Remember, all of you, if z is less than 0, if z is less than 0, when you are multiplying, then the sign of the inequality will be changed. Matlab less than will be greater than, less than will be greater than. If you are having here less than equal to, then it will be greater than equal to. ठीक है? ठीक है? When you are multiplying a negative number to the inequality, then the sign of the inequality will be changed. This is the simple rule. When we are multiplying a negative number to the both side of inequality, then the sign of the inequality will be changed. Is that clear to everyone? When we are multiplying a positive number, the sign of the inequality will remain same. Clear, everyone? Done? Okay. Come to the third rule. Third rule is saying division property. Similarly, है ना? If x is less than y and z is greater than 0, the sign of the inequality will remain same. ठीक है? Like this. Fourth rule is saying if x is less than y and sorry, x is less than y is the inequality is given. If z is greater than 0, if you are dividing z on both sides, if you are dividing z on both sides, then the inequality remains same. Okay. But if z is less than 0, if z is less than 0 and you are dividing on both sides, then the sign of the inequality will change. The less than becomes greater than becomes less than. When you are dividing a negative number on both sides of inequality, then the sign of the inequality will be changed. That means less than becomes greater than becomes less than equal to becomes greater than equal to becomes less than equal to, right? This is the fourth rule. And fifth rule is transitive rule. See what is given here. Okay, if x is less than y, inequality is given, and y is less than z, then x is less than z. Okay, this is the fifth rule. Okay, so these are few rules we should know about we should know to solve the inequality, right? To solve the inequality, we must know all these rules, right? Let's learn. These are the same things here. It is written: equal numbers may be added or subtracted both sides of an inequality without affecting the sign of the inequality. This is the first two rules we have discussed. And both sides of an inequality can be multiplied by the same positive number, but when both sides are multiplied or divided by a negative number, then the sign of the inequality will be reversed. Is reversed, right? Reversed means less than becomes greater than becomes less than. That's all. Okay, these are few rules. Okay, remember all these things. Okay, now we'll see graphical representations of linear inequality in one variable. So how we can represent inequality in graphically linear inequality. Okay, so solution in open bracket. Suppose we are having simple thing. I'm explaining here. No need to. Okay, okay. Suppose all of you know what is open interval, what is closed interval, what is semi-closed or open interval. Open interval means, suppose here I am taking 2, 3 open interval. That means here the endpoints are not included. Okay, except the endpoints, all the real numbers between 2 and 3 will be belongs to this interval. Okay. If I'll take 2, 3 closed interval, that means here in this case the endpoints are included. Okay, and semi-closed or semi-open, that means here suppose I'm taking 2, I'm giving closed bracket with 2 and open bracket with 3. So when with which number, with which n you are having open bracket, this is open bracket. Okay, when you are having open bracket, that means that n is not included. So it is not included. And when you are with which number you are having closed bracket, that number is included. Okay. So how we can represent these intervals? They are called intervals. All of you know, I think. Okay. So how we can represent these intervals on number line? Like here, first interval can be represented by like this. Suppose this number is 2, this number is 3. Okay. So we can represent on number line like this. Because the endpoints are not included, I am giving hollow circle, and this black region, black area is your set or is your interval excluding the endpoints. This is represents to open interval 2, 3. So how we can represent closed interval of 2, 3? Like this. Suppose this is 2, this is 3. So including the endpoints, that means 2, 3 are included. So this set is called closed interval of 2, 3. All the real numbers in between 2 and 3, including the endpoints. But in this case, in the first case, all the real numbers present in between 2 and 3, excluding the endpoints. Clear, everyone? So how we can represent this interval? Like this. So this number 2 is included and 3 is excluded. And this is your graphical representation. Okay. Now also we can represent by like this also, above the number line also. When not included, I am giving hollow circles. When they are included, I am giving dots. Okay. Okay. These are the graphical representation of the intervals on number line. So here solution. Suppose another thing is also there. So these are if the solution of an inequality is open interval of xy, we can represent it by like this. If the solution set of an inequality is only xy, the set contains only xy, then only I am giving what? I am giving only dots on xy. Because x and y are only the solution points. Okay. Solution in closed bracket already we have discussed. Solution in semi-open or semi-closed, like this we have discussed already these things. I hope these things are clear to everyone, guys. I hope these things are very clear to everyone. These are the very basic things about the inequality. Let's move. Now, linear inequality in one variable, inequality representation on number lines. Okay. So suppose x is greater than 2, how we can represent it? X is greater than 2, that means x is not equal to 2. That's why at the point 2, I am giving hollow circle here. And x is greater than 2, that means this red line, red arrow represents to your solution set, and in the interval we can represent x belongs to 2 to infinity. 2 to infinity when 2 is not included. And remember, one most important thing is when you are including the infinity in the solution set, so with always remember, with infinity always you have to give the open bracket. Okay, open bracket always. Okay, because we don't know what is infinity. Infinity is very big. Okay, outside of our imagination also. Okay, x is greater than equal to 1, we can represent. How we can represent? Here 1 is included, right? Here 1 is included, and this green arrow represents to your solution set. 1 to infinity, 1 is included, infinity is infinity. X is less than 1. From the figure, all of you can see or can observe all the solutions set, how we can represent the solutions, intervals. All of you know, already we have discussed all these things. So let's solve one inequality and let's understand how we can represent the solutions on number lines. Okay. So here one inequality is given, x by 2 is greater than equal to this inequality, 5x minus 2 divided by 3 minus 7x minus 3 divided by 5. So how we can solve with this inequality and show the solution on the graph. Okay. So x by 2, write the inequality here. Okay. In the right hand side of the inequality, I am taking the LCM. LCM is 15. Okay. 5 into 5x minus 2 minus 3 into 7x minus 3. Okay. After taking the LCM, we got this. Okay. Then simplify the right hand side. After simplification, we are getting x by 2 is greater than equal to 4x minus 1 upon 15. 4x minus 1 upon 15. Right? Now, if you cross multiply, okay, if you will multiply 15 on both sides, not cross multiplying, what I am doing, I am multiplying a positive number on both sides. Okay? I am multiplying a positive number on both sides and dividing okay, dividing no, let's see. Here we are multiplying a positive number 15 on both sides and also multiply 2 on both sides. Okay, after multiplying 15 and 2 on both sides, what you are getting? Here 2 will be cancelled out. Here 15 will be cancelled out. So you will get this inequality. 15x in the left hand side, what you are having? 15x is greater than equal to 2 into 4x minus 1. Right? So 15x is greater than equal to, after simplifying the right hand side, you are getting 8x minus 2. 8x minus 2. So if you'll subtract 8x from both sides, if you subtract 8x from both sides, we are getting 15x minus 8x, that is 7x, is greater than equal to 8x minus 8x will be cancelled out, minus 2. So 7x minus 7x is greater than equal to minus 2. If I'll divide positive 7 on both sides, what we will get? We'll get x is greater than equal to minus 2 upon 7. X is greater than equal to minus 2 upon 7. So minus 2 upon 7 gives you 0, minus 0 point something. Okay, minus 0 point something. 0 point something means minus 0.2, like this. Okay, so minus 0 point something. So first plot this number on the number line. This, suppose this number is minus 2 upon 7, right? And we need the interval. So what is the interval? Interval is x is greater than, x belongs to minus 2 upon 7 to infinity. Minus 2 upon 7 to infinity. So this, if this point is minus 2 upon 7, then the solution region will be this. So this red arrow represents to your solution set. Okay? I hope this is clear to everyone, guys. Clear? Clear, guys? Let me know in the chat box if it is clear to all. If you are having any doubt, you can ask also. कोई doubt है इसमें? Any doubt? Okay. ठीक. चलो. Let's move. Next question. Next question. Minus 15 is less than 3 into x minus 2 upon 5 is less than equal to 0. So here we are having this type of inequality. So how we can solve it? First we will take minus 15 is less than 3 into x minus 2 upon 5, and another thing is another inequality we can take 3 into x minus 2 upon 5 is less than equal to 0. So solve this first, then solve the second one. By solving this one, how we can solve the first one? Minus 15 is less than this. Okay, so if you multiply 5 on both sides, if we multiply 5 on both sides, we'll get minus 75 is less than, here multiply 5 on both sides. We'll multiply 5 on both sides, we are getting minus 75 is less than 3 into x minus 2. Okay, now open the right hand sides. After opening the right hand side, what are you getting? We are getting, say, minus 75 plus 6 is less than this. Okay, finally we are getting minus 23 is less than x. Minus x is simply less greater than minus 23. We are getting here. Okay, that means x belongs to minus 23 to infinity. Okay, but in the second inequality, another inequality, what by solutions, what you are getting? First multiply 5 on both sides. Okay, we are getting 3 into x minus 2 less than equal to 0. Okay, then divide 3 on both sides. After dividing, we are getting x minus 2 is less than equal to 0. So finally we are getting x is less than equal to 2. Okay, that means the solution set is x belongs to minus infinity to 2. 2 is included, right? Here in this case, minus 23 is excluded because we are having greater than sign, and here 2 is included because we are having less than equal to sign. Okay, so first we'll represent the first interval, that is minus 23 to infinity. Minus 23 to infinity represents this line, this arrow, because we are minus 23 is not included. Like this also we can take minus 23 is not included, and minus 23 towards infinity. This red line represents to this interval. Okay, and the next thing is minus infinity to 2. Minus infinity to 2. That means minus infinity to 2. 2 is included, right? 2 is included. Then the what is the intersection area? What is the intersection region you are getting between both the arrows, between both the solution sets? What are the intersection area you are getting? These are, है ना? This is my intersection area. Okay, so this is my intersection area. So then the solution set will be minus 23 is not included. Minus 23 is less than only less than x less than equal to 2. Okay, minus 23 less than x less than equal to 2. That means x belongs to minus 23 excluded, 2 included. Is that clear to everyone now? Clear? Done? Done, guys? Okay, let's move to the next thing. Another example here. Minus 12x is greater than 30. Minus 12x is greater than 30. When x is an integer, first question, when x is a natural number. You need to solve. Right? So if you'll solve minus 12x is greater than 30, if you'll divide 12 minus 12 on both sides. Okay, minus 12 on both sides if we'll divide. then the sign of the inequality will be changed because we are dividing the any negative number, right? So after dividing, what we are getting, x is less than minus 5.2. Okay, minus 5.2, that is 2 minus 2.5. Okay, minus 2.5, where is it? Minus 2.5. This number represents to minus 2.5. So we need x is less than minus 2.5. That is, x belongs to minus infinity to minus 2.5. Okay, is it? Is it or not? No. Why? First question is saying x is an integer. We need the solution. We need the solution when x in the solution set, the solution must be an integer. The solution must be an integer. That means those numbers are integer. Solution set is those number are integer, which is those are less than minus 2.5. Less than minus 2.5 integers are infinite number of integers you will get, like minus infinity to minus 5, minus 4, minus 3, all these things. Okay, up to minus 3, minus infinity to minus 3, all the integers in between minus infinity to minus 3. Is that clear, everyone? Okay, then the solution set for the first one is minus 4, so on, minus 3, minus 4, minus 5, and so on. Okay, and the second, for the second one, the natural numbers less than minus 2.5. Natural numbers less than minus 2.5. Is there any natural number minus, those are less than minus 2.5? There are any natural numbers in दुनिया में कोई है ऐसा नेचुरल नंबर जो माइनस 2.5 से छोटा होगा? नहीं, ऐसा कोई भी नहीं है. There is no solutions. So for the second one, there is no solutions. Is that clear, everyone? Clear? Clear or not? Okay, if it is clear, let's move to the next thing. Here is one inequality. Now we'll go through wavy curve method, the most important thing. Okay, we use this method to solve the inequality of the form, like when it will be in a polynomial form, when the inequality, in the inequality, you are having the inequality with the polynomial form or in the rational form, right? In the rational form. Okay, we can apply the wavy curve method to solve those inequalities. Let's understand this method by taking one example, right? By taking one example. So what it is saying actually? What it is saying? ठीक है? What it is saying? Make sure the right hand side is 0 and the coefficient of all of x in all the factor is positive, right? Make sure the right hand side is 0 and the coefficient of x in all the factor in positive is positive. Let's take an example to understand this. Okay, so I'm taking this one, x minus 3 into x minus 3 into x minus 4 whole square. Remember all these steps, huh? What I'm doing, just remember those. Divided by x minus 5 ki cube greater than equal to 0. How we can solve this inequality? Okay, how we can solve the inequality? The first step is saying make sure the right hand side is 0. Yes, we are having 0 in the right hand side. Right hand side, in right hand side we are having 0. No need to do anything. Okay, if not, you are not having 0, make it 0. And the coefficient of x in all the factor is positive. Make sure in all the factors in the inequality, what are the factors are present? What are the factor present? In all the factors, the coefficient of x must be positive. Yes, here we are having coefficient as 1. Here we are having the coefficient as 1. Here we are having the coefficient as 1. In all the factors, we are having positive coefficients. So in all the factors, second step, first step done, right hand side is 0. And in the second step, in all the factors, coefficient of x is positive, are positive. So first step, second step is done. Now, if this is done, put all the factors equal to 0 and mark the corresponding values of x on real line. Okay? Then put all the factors equal to 0. That means find all the critical points. Next step is find all the critical points. Learn these things. It's very much useful thing. Yeah? Critical points. What is critical points? How we can find critical points? Now by taking all the factors equal to 0. So x minus 3 is equal to 0. So x critical point is 1 critical point is 3. X minus 4 is equal to 0. So another critical point is 4. X minus 5 is equal to 0. So next critical point is 5. So these are three critical points here I am getting. So critical points are 3, 4, 5. Here we are getting. After getting all the critical points, write all the critical points on the number line, plot all the critical points on the number line. Okay. Now I am plotting all the critical points on the number line. Okay. I am plotting all the critical points on the number line. This is my 3. This is my 4. This is my 5. Okay. Okay. Next thing is take a, okay, what is the greatest number in between these critical points you are getting? That is 5. So, or we can say in the rightmost side of the number line, what is the number is available? That is 5. 5 is available at the rightmost part of the rightmost side, right at the rightmost side of the number line. 5 is present, right? If you will take a greater positive number, if you will take greater number than 5, if you will take a number which is greater than 5, okay. So next step is first plot all the numbers on the number line. Next step is saying put positive on the extreme side and start moving towards left. If you encounter an odd path, let's okay, that is the method. What I am saying, any number you can take greater than 5, and if you put in the inequality, you will get a positive. If you will get a positive number, if you will get a positive number like this, if you will take 6, which is greater than 5, and if you will put 6 in the given left hand side, if you put this 6, x are 6 in the left hand side of the inequality, what you are getting? Let's see. 6 minus 3 is 3. 6 minus 4 is 2. 2 square is 4. So 3 into 4 is 12. Okay, 12 upon 6 minus 5 is 1. 1 cube. So 12. 12 is greater than 0. One positive number you are getting. That's why what I'm doing, always remember, put positive, always put positive on the extreme side, extreme right. Put positive always on the extreme side. I am putting here positive sign on the extreme side of the number line. Here I am giving positive sign. Okay, because you can see now when we are taking a greater number than 5, if we are putting that number in the number line, sorry, left hand side of the inequality, what you are getting? After putting, you are getting a positive number. That's why all the numbers, for all the numbers greater than 5, if you will put those numbers in the left hand side of the inequality, you are getting positive values. That's why after 5 you are getting positive values for the inequality, for the left hand side of the inequality. Is that clear to everyone? Clear everyone, guys? Yes or not? If it is clear, then next step is saying come to the point, come to the rightmost point, that is 5. Come to the point 5 first. Okay, come to the point 5 first. So check in the inequality, in the given inequality, which is the, go to the corresponding factor of 5. Corresponding factor of 5 is 3. Sorry, corresponding factor of 5 is x minus 5, right? इसका जो corresponding factor है, that is x minus 5 to the power 3. Okay, to the power 3. So here next thing is you need to, देखो थोड़ा लंबा लगेगा, lengthy लगेगा, but after solving a lot of questions, 3 to 5 questions, you will be very familiar with this method and you will love this method. I am giving you guarantee you will love this method. Okay, so you can see here you are having a power here. First give the positive sign, give the positive sign at the right most part of the number line, then come to the first point, that is first number, that is 5, and go through the corresponding factor of 5, that is x minus 5, and check what is the power is given in the corresponding factor. Okay, what is the power is given with that factor. So here we are having the power as 3. Check whether that power is even or odd. Check whether that power is even or odd. If it is odd, what if the coefficient of x is not positive? If the coefficient is not positive, make it positive. If the right hand side is not 0, make it 0. Then you can apply this rule, right? Clear, Bhavna? JNB Bhavnagar? Okay. Okay, clear? If the coefficient of x is not positive, make it positive. If the right hand side of the inequality is not 0, make it 0. Okay. Okay, now check the power of the corresponding factor, that is x minus 5. Here we are having the power is 3. Okay, so 3 is an odd number. If you are getting an odd number, how? And please give next example of that one. Let's see. How means how? What is how? Like this. If you are having x minus 5, okay, if you are having x minus 5 into x minus 4 into 1 minus x is less than 0, right? So first make the coefficient positive. That means you need to multiply -1 on both sides. If you multiply -1 on both sides, we will be having minus of x minus 5 into x minus 4 into x minus 1 is greater than is less than 0. When you are multiplying a negative number, the sign will be changed, right? Greater than 0, right? So finally we are having this inequality. After multiplying negative on both sides, -1 on both sides, you are getting this inequality. So then divide -1 on both sides, right? After dividing, we will be getting x minus 5 into x minus 4 into x minus 1 is greater than 0. Again, after by dividing -1 on both sides, you will be getting greater than 0. The sign will be changed because you are dividing what? -1 on both sides. Is it clear? Like this inequality, make it positive. Okay, make the coefficient always positive. Is it clear? Clear, beta? JNB Bhavnagar, is it clear? Like this, in this way. Okay, and suppose you are asking, sir, x minus 5 is greater than x minus 4. If the right hand side is not equal to 0, okay, then you have to make right hand side, make sure we can apply that wavy curve method when the right hand side is 0. Otherwise we cannot apply. If the right hand side is not 0, we can't apply. So here how we can make this right hand side become is 0. So if we'll divide x minus 4 on both sides, we can't divide. If the right hand side is not 0, we cannot apply the Webber method. Simple. It can't be make right hand side can't be make 0. So if we'll how we can solve this inequality, x minus 5 minus x minus 4 is greater than 0 in this way. Okay. If the right hand side is not 0, then we can't apply the Webber methods. Let's come to the method. Okay. Chalo. Okay. Forget about it. Okay. So now if you are getting odd number, then give in the next interval, give negative sign. Okay. If you are getting odd number, then in the next interval, give the alternate sign. That means here you are having positive, then you need to give your negative. Okay. Similarly, come to the next point 4, and 4 corresponding factor of 4 is x minus 4 whole square. So here you are getting one even number, here even power. Here you are getting even power. When you are getting even power, then you need not change the sign of the in the intervals, like negative sign again remains same. When you are getting even power, the previous sign will remain same. Okay, here in the previous sign we are having negative, so negative will continue to the next interval. Okay. If you are having here positive sign, then the positive sign will be continuing to the next interval, right? Next point is 3. Okay, next point is 3. Come to the point 3. Point 3 and 3 ka jo corresponding factor hai, that is x minus 3. His power is 1. Here you are getting one odd power. Here you are getting one odd power. So when you are getting odd power, we need to change the sign. That means negative becomes positive here. In this interval, negative becomes positive here. And we are having here greater than equal to sign. That means equal to signs means after doing all these things, check whether at all the critical points my inequality is satisfying or not. Important thing is check whether at all the critical points my inequality is satisfying or not. That means here we are having 5 at point 5. At point 5, is my inequality satisfying? If you'll put x as 5, if you'll put x is 5 in the given inequality, is the inequality satisfying? No, because at x is equal to 5, the left hand side of the inequality will not be defined because the denominator becomes 0. That's why here I am giving one hollow circle. Okay, here I am giving one hollow circle. Okay. Similarly, at point 4, is it satisfying? The inequality is satisfying at x is equal to 4. Yes, it is satisfying. If we'll put x is 4, then the left hand side becomes 0. So we need we have less than equal to sign. So it may left hand side may be 0. Left hand side can be 0. That means 4 is included, right? 4 is included. Okay, 4 point is included. Then come to the number 3. At x is equal to 3 also the inequality is satisfying. That means if you put x is equal to 3, the left hand side becomes 0. That means it is also included. Okay. Now finally we need the solution set. How we can find the solution set? We need the greater than, the reason those are positive and equal to 0. Those are positive and equal to 0. Okay. Those are positive and equal to 0. Let's see. Positive reason. What are the solution set will be? Let's see. Solution set will be positive reason. That means here, these are my positive reason. Greater than 5 and less than 3 and less than 3. Greater than 5 and less than 3. These are my solution set. So why we are okay? So solution set will be x belongs to minus infinity to 3, 3 is included because at point at x is equal to 3, at x is equal to 3 inequality is satisfying. Union positive greater than 0 na, greater than 0 positive, that is 5. 5 is excluded because at x is equal to 5 inequality left hand side is not defined, 5 to infinity. So this is my solution set for this inequality. This is my solution set for this inequality, right? So why we are calling this, why we named this method as wavy curve method? Because if we'll draw a wavy curve, okay, if we can draw a very good wavy curve also. So how? When you are getting positive sign, always remember from the rightmost part, start the curve like this way. And when you are having odd power, when you are getting odd power, cross the first method already I have discussed. This is the second method we can draw also. Okay. So when you are having, okay, start the graph from the upper part of the inequality and reach the point 5. Check whether at the point 5 you are having odd power or even power. If you are getting odd power, change the side of the number line. Change the side of the number line. Okay. And reach the point 4. At point 4, we are getting even power. At point 4, we are getting even power. No need to change the side. No need to change the side of the number line. Continue with the same side of the number line. That means when you are getting same sign, so continue with that side only. Okay. When you are getting even power, we need to continue with the same side. Then reach the point 3. Then reach the point 3. At point 3, we are getting even odd power. That means when you are getting odd power, we need to change the side of the number line. Change the side of the number line. Now we can see what are the positive reason we are getting. We are getting the positive reason are this positive reason. These are my positive reason. These are my positive reason. Okay. So this is called my wavy curve method. We'll solve one more examples that's which will be easy to understand or easy to remember the method. Let's move to the next example. Okay, these are few. Take a screenshot of this of your screen. These are few inequalities. You need to remember the solutions. How the solutions will be. Take a screenshot of your screen. X minus a into x minus b less than 0, the solution will be open interval of AB, where a is less than b. Okay. X minus a into x minus b is greater than 0. If you are having this type of inequality, the solution set will be like this: minus infinity to a union b to infinity, where a and b are not included. Right? When x square is less than equal to a square, then the solution set will be x belongs to minus a to a closed interval. Like this. Take a screenshot of your screen. Okay? Let's move to this example. Now, by using the wavy curve method also, we can solve this question. How we can solve it? So first make sure all the coefficient of x must be, make sure the right hand side of the inequality is 0, and make sure all the coefficient of x is positive. X is positive, but here we are having one coefficient, that is minus 2 is not positive. Minus 2 is not positive, right? Minus 2 is not positive. Clear, everyone? So make it positive first. To make this inequality, to make this factor as to make the coefficient of x in the third factor in the left hand side positive, what we will do? We will multiply negative 1 on both sides. If we will multiply negative 1 on both sides, it becomes x minus 1 into x minus 2 into 2x minus 1 is less than 0. When you are multiplying a negative 1, the sign of the inequality will be changed. Clear, everyone? ठीक है. अगर ये हो गया, now we can use the wavy curve method. Simplify, for your simplification also, we can make the coefficient of x as 0, x as 5 to infinity, 3 to 4. Already you have solved. Very good. 5 to infinity, the solution of this inequality. You are telling the solution of this inequality. JNB Kolhapur. 5 to infinity, 3 to 4 is your solution. No. In the last example you are saying. This is for your understanding. JNB Kolhapur, what you have written, what is that actually? I'm not getting you. Okay. Chalo. So now, for your simplification, you make all the factors having matlab make all the coefficient of x as 1. You can make it like this. So if you'll divide, if you'll take 2 common from the third factor, okay. So 2, if you'll take 2 as common from the third factor, x minus 1 into x minus 2 into x minus 1 by 2 is less than 0. Okay. Like this also you can do. Okay. So if you'll solve this one, these two, you can solve any one. Okay. The result will be same. Okay. Now, what you have written in this? Here we don't have any solutions. Okay. This one. 5 to infinity. Yes. Minus infinity to 3. Correct. Chalo. ठीक है. Okay. Previous question. The solution is 5 to infinity union 3 to 4. Previous question means this one. This question. Three to 4. For this one you are telling, JNB Kolhapur, for this one you are telling, previous question means this one, 5 to infinity union 3 to 4. No, beta. No. The solution, already I have solved the question here. Okay. Already I have solved the questions. Minus infinity to 3. Okay. Minus infinity to 3. And 5 to 3 to 4. You are telling 3 to 4. In between 3 to 4, if you choose previous questions, okay. This one, beta, this one. This question. You are asking this question? Yes, okay. Thank you. Chalo, theek hai. For your understanding, I have taken this one. Okay, I am not solving this one. Huh? It's very easy. Okay, let's see. The next is solve this one. Now, solve this one by using the Webby curve method. We can solve this how? Dekho, what are the critical points? First, write all the critical points. One is plot the number lines first. I am plotting the number lines. And what are the critical points? One is 1, 2, 1 by 2. 1, 2, 1 by 2. 1, 2, 1 by 2. So 1 by 2, 1, 2. So these are my critical points, right? And start from the right upper right part. Okay. Blindly give positive sign. I am telling you, blindly give positive sign. If you will take any greater number than 3, any number greater than 3, and you will put that number in the left hand side of the inequality, you will get positive. You will get positive values. Okay. You will get positive values. Okay. Come to then reach the point 2. The corresponding factor of point 2 is x minus 2 and the power is 1, then you are getting odd power. Then the sign of the sign will be changed positive to negative. Or in all the factors you are having odd power. In all the factors you are having odd powers. Okay. So that means the sign will be alternate. So here negative becomes positive. Here positive becomes negative. Is easy. So we need only the negative reason, right? Yes. X minus 3 into x minus 4 upon x minus 5. This question. X minus 3 into such type of question. This question actually I have solved already. If you are getting any solution, other solutions, please check it with it. Okay. And if I did some calculation error, please check it again because it is time. I will discuss, I will check the solutions. I will solve it again and will tell the answer again. X minus 3 into x minus 4. Previous question, yes. What you are saying, I am not getting you actually. Okay, let's. You are having write in details. In which question actually you are having doubt? What is the solution set you have written? That solution for which question you have written? You tell me what is for the previous question. That means from the this is one example I have taken for this one or this one. Okay, chalo. Okay, now we got this one. We need only the negative reasons. We need only the negative reason here. So what are the negative reason we are getting here? We are getting here, and finally after giving the signs to the number line or to the all the intervals. Okay, now check at all the critical points. Because we are having only less than sign, we don't have any equality signs, so we need to give here hollow circle. At all the critical points are not included in the solution set of the inequality, right? So we need only the solution set will be, we need only the negative reason, that is this reason, negative 1, this. The solution set will be x belongs to minus infinity to 1 by 2 union 1 to 2. The solution set of this inequality is minus infinity to 1 by 2 union 1 to 2. Clear everyone? Let's see what is the solution. Minus infinity to 1 by 2 union 1 to 2. This is the solution. Okay, clear everyone? Clear? Okay. So first what we will do, first of all check, make sure the right hand side of the inequality is 0. If it is not 0, we can't apply the Webber curve method. And then check in the left hand side what are the factors you are having. In those factors, the coefficient of all the coefficient of x must be positive. If they are not positive, make them positive. After making them positive, plot or find all the critical points, plot on those critical points on the number line, then give the sign convention, like start the solution set, like give the positive sign in the rightmost interval of the number line. Okay, then starting from positive sign, reach the first point from the right side, reach the first point, check the corresponding factor of that first point, whether it is even or odd. If it is even, then continue with the same sign or continue with the same sign. If it is odd, change the sign. Okay, after doing all these things, check at all the critical points whether the inequality is satisfying or not. If it is satisfying or not, then check what is the reason you are what is the reason you need. Actually, you are having less than sign, or you are having less than equal to sign, or you are having greater than sign, or you are having greater than equal to sign, right? Likewise, you have to find the solution set. Okay, so this is all about your Webiker methods. In the next class also, we'll take some more examples, and it will be easy to remember the methods, and you can solve the questions easily. Right? Thank you all. Bye bye. Take care, everyone. Bye. It's time to end your class. Bye bye. JNB Kolhapur. Now you can ask. I have time. Okay. If you are having any doubt, you can ask.